One of my clients called me up and said, "Hey, I've got this compression chamber from a jet engine. We should do something cool to display it." And I was like, "You have a what?" So this is what we came up with. The engine came in this really heavy crate standing on end. So the first task was to figure out how to get it out of the crate and turn sideways. At this point, I wanted to preserve the crate so I could use it to ship the engine back to the client if I needed to. So I didn't want to just cut the crate open and roll the engine out. So to help get it out, I welded up a piece of tubing with a spacer on it to keep it locked into place, and I hooked it up to my engine hoist to pull it out of the crate. Now the design dictated that the engine needed to be on its side, and I didn't really have a plan on how to do this once it was out of the box. This is probably an 800-pound range engine, so I just didn't want to lay it on the side and risk bending the fins. So I built a blocking rig out of some scrap wood to tip the engine on. After playing a little Tetris, I finally got it situated. The center opening that ran through the engine was wider at the front than it was at the back by about an inch. So I welded up a little bracket out of some steel tubing with an offset on one end so the engine would sit level when it sat in the crate. This was important so I could take accurate measurements and figure out how it was going to be suspended in the table. Once I got the engine situated in the crate, I started working on the base for the table. I milled up some 8/4 lumber for the legs. I figured I needed something substantial to support the weight of the engine. I took my time orienting the pieces so when I glued them together the grain direction would help disguise that it was made out of two parts and look like one solid leg. Once I was satisfied, I glued them up. I set up a stop block on my table saw and cut all the legs to the same length. I oriented the legs so the nicest side faced outwards and then took some time to lay out all the joinery. I used my router to cut the mortises. Since I didn't have a bit on hand that was wide enough to do it all in one pass, I just took multiple passes with a smaller bit to get the job done. Since rounded tenons are lazy, I used my chisel to square up the mortises. Moving on to the aprons, I milled and cut them to length. To be sure they came out all the same length, I set up stop blocks for cutting the final passes. I set up a dado stack to cut the tenon cheeks with the sacrificial fins and readjusted as I went to get the length that I wanted. It took a few passes. The top and bottom shoulders of the tenons are going to be cut at different offsets, so instead of creating multiple setups at the table saw, I decided to cut those by hand. I used a knife to mark the cut line. This does a few things: sever the fibers so you get a cleaner edge, and gives the saw something to track against to give you a straighter cut. To help facilitate the saw tracking against the kerf, I used my chisel to create a channel about the width of the saw blade on the waist side. Doing a little test fit. It was a little tight, so I used my shoulder plane and worked down the sides of the tenons until I was satisfied with the fit. There's going to be a center support that holds one end of the engine up. This support is going to hang from the apron using a bridle joint pinned with a through tenon. So I started out with a jig the width of the center supports and routed out a date on each side of the apron. Then I marked out the location of the bridle joint on the pieces that are going to hang from the apron and used the table saw to establish the outside edges. This is a key joint, so I wanted it to fit snug as I could, so I chiseled out by hand the waist, creating a flat bottom to set against in the apron. That's a very satisfying fit. Moving on to the support piece. This is what the end of the engine is going to rest against. These are going to be through tenons to give it some decoration as well as strength. So to keep the shoulders looking good and sharp, instead of using the dado blade to cut the cheeks, I stood the workpiece up on end and cut them with my shop jig. This is a much cleaner cut than using the dado blade since it doesn't leave a bunch of lines on the tenon sides. Then I reset the saw to cut slots for the wedges to wedge the tenon in place when I do the final assembly. Then to make sure the wedges don't split the wood, I drilled some relief holes. Then I made a quick template around the tenon and then used that to route out the mortises. To route out the mortises, I used a pattern bit to follow the template. And then finally a little chisel work at the bench to square up the mortises. I of course did a test fit to be sure I was happy with the fit. Then I cut it to its final length. Since this is going to carry some substantial weight, and I didn't want the weight to blow out the bottom, I set up my router table to route out a groove in the bottom of the support so I could glue in a spline across the end grain. I think this added a considerable amount of strength. Then it was time to glue up the sub-assembly for the aprons. Even though it was a good snug fit, I still clamped the joint to be sure I got good contact between the two pieces. Once that piece was dry, I glued on a support strip that is going to be attached to a steel frame to add some more strength to hold the engine, as well as rigidity to prevent the aprons from sagging over time since it's going to be under constant load. I used a piece of angle iron to be sure it was spaced out properly when I glued it all together. While that was drying, I moved on to figuring out how to suspend the engine in the base so that it was level and so that the glass top would pass directly through the center. I scribed the shape of the engine onto some plywood and cut it out at the bandsaw. I kept refining this shape with the spindle sander until I had a nice fit around the engine and it was perfectly centered. I did a dry fit of the frame and used a strip of plywood the thickness of the tabletop to suspend my plywood template from. This gave me the exact location where I needed to cut so the engine would be cradled in the perfect position. I marked its position on the cross brace and routed out a ledge for the engine to sit on. The front of the engine was stepped, so I recut my template to create a stepped effect and routed it out again. I continued this process until all the steps into the cross brace fit snugly to the engine. So now before I do the final glue up of the base, I need to take care of a few final details. I wanted the legs to have a slight taper on the outside, so I made a quick makeshift jig and cut the taper on all the legs. Then I wanted to put a peg in the center of the bridle joint, so I made another quick jig. This peg adds another layer of ornamentation to the piece as well as a layer of strength if the glue bond were to ever break. I milled some stock to fit my peg and cut a slot for the wedge, then cut them to their final length and glued them into place. I glued the center support piece up as a sub-assembly, then I moved on to gluing up the legs. When I cut the tapers, I made sure I saved the wedge-shaped cutoffs so I could use them as a clamping caul. It's a lot easier to clamp against a square surface than it is to clamp against a tapered surface. Once the sub-assemblies were dry, I broke out the long clamps and glued all the assemblies together. At this point, I did do a test fit to be sure the engine sat in there nicely and discovered that the wood held the weight just fine. It didn't even grunt or groan. But I still wanted the reassurance that over time the apron would not sag under the constant weight. So I cut some angle iron, drilled some attachment holes, and fitted it to the base. I marked out the shaft location and cut the arch using my angle grinder. Any place where the edge of the steel could be seen if you were standing back from the table, I cut a decorative arch to dress it up. Then I set everything in place to make sure it would fit nicely, and I tack welded all the parts together. As not to burn the wood, I pulled it out to do the final welds and welded on some clips to screw the top down when it got to that point. I cleaned up the welds and painted the whole thing black. Then I screwed it in place and dropped the engine in to be sure everything was just right. I packed up the base out of the way and went to work on inlaying the engine into the slab. I used a flexible curve finding strip to follow the general curve of the engine and plotted it out on a plywood template. I did a few test fits as I went. The slab I picked out had some cool burls on it that I wanted to be sure to incorporate into the final design, so I used my template as a guide and positioned it around the burls I wanted to save. Then cut it to length. The slabs are too wide overall, so I cut out the center of the slabs and re-glued the outer edges back together. I gently clamped them up with my parallel clamps, trying not to break the live edge. Then I added some glue blocks down the center so I could be sure to pull the seam tight. A slab with all that burl wood was crazy expensive, so before I started to cut into it, I cut the shape of the engine out on some craft paper. This way I could position it on the slab to be sure I had it laid out in the perfect spot. I used my jigsaw to rough cut the shape of the engine out and followed that up with my router and a pattern bit, which followed the template perfectly. On the inside corners where the router bit couldn't get, I cleaned them up by hand with a mallet and chisel. Now the back was a little interesting. I scribed the gear shaft to get the general shape. Then I stood it up and clamped it to my workbench and used a pattern to cut the round shape of the shaft. Then I rough cut the waist off and then chiseled to my scribe line. I set it all back up and then cut the tops to their final length. There was a spot where Mother Nature did not want to cooperate with my design idea, so I took a power carver to it and sculpted the edge to fit my design. Once I was satisfied with the fit, I rolled out some trace and traced the shape of the grain where I wanted the glass to be inlaid. I created a plywood template and sent it off to the glass company so they could use their water jet to cut the shape out. So while I was waiting, I started cutting the strips for the bent lamination arch. I cut all the strips out on the bandsaw and then ran them through the drum sander to remove the saw marks. Off camera, I used some walnut plywood to create a bending form. I show how to do this in a past video. If you're interested in the process, you can go back and check that one out. After it was dry, I used a card scraper to clean up the bulk of the glue squeeze out before running it across the joiner. Then I did some layout to figure out all the angles for it to set up a little jig at the table saw to hold the pieces in the right orientation to the blade. Once I had the arches dialed in, I milled up some lumber for the cross braces. I temporarily clamped the arches in place so I could lay out the brace locations. Then it was a matter of just doing some hand chiseling. The through mortises need to be at an angle to follow the path of the arch, so I worked from each side chopping at an angle until I met in the middle. From there it was some test fitting and pairing until I had a nice fit. I took care of some final details like pairing a chamfer on the ends of the tenons, and then I took all the parts into the finishing room to stain them and pre-finish before the final assembly. Since everything was pre-finished, when I did the final assembly of the arches, I took care to mask everything off not to get glue on the finish, and then I just used an epoxy to give me the extra working time to get all those pieces put together. Then I made sure each one was square as I seated them. The glass is back, but there was a slight problem. Even though I sent them a hard template of the shape I wanted them to cut out, they could not figure out how to get such a complex shape into their computer to create a toolpath for the water jet. So I scanned in my original paper template and used it to create a toolpath. There were a few spots where the scan was ambiguous, so I had to redraw them. I knew these spots would not be exact to my wood template, so the glass may not fit as nicely in those areas as I wanted. So to combat that, I glued some felt on the bottom of my router base so it wouldn't scratch the glass, and with extreme care and maximum butt pucker factor, I carefully cut a new template to use. I positioned my template on the table and routed out the shape to fit the glass. One final detail before assembly was to stain the edge. When looking at slabs, the client liked the contrast of the edge from the bark, but bark doesn't always stay on the edge after the slab is dried. So I diluted down some stain that I used on the base and stained the edge of the slab where the bark was and sealed it in with some poly. Then it was time to set it all up and take some portfolio pictures. If you want to know more about this project, I have a highlights reel on my Instagram that shows more behind the scenes stuff on how all of this came together, and of course more pictures are on my website. Thanks for watching, and of course like, subscribe, hit the bell, share, follow me on Instagram, join me on Patreon, whatever you want to do, just do something. Thanks for watching.